Hello everyone, I'm Frank and welcome to Frank Puzzles, and this is today's average level difficulty puzzle, and it's called Rhubarb and Custard by Codec. And here are the rules. Sudoku. Each row, okay, we can get a row here. Each row, column, and region indicated by thick borders in the grid, so this is a box, thick borders, in the grid must contain the digits 1 to 9 once each. So that's normal Sudoku rules. Little killers, digits along diagonals indicated by arrows outside the grid, must sum to the given number at that arrow. So, for example, these two cells must add up to 3. These 4 cells, I'll get there eventually, must add up to 25. These 5 cells must add up to 30. These 9 cells along this diagonal, I'll get there eventually too, must add up to 71. These 9 cells along this diagonal must add up to 21, etc., etc. And that's what a little killer clue is. I'm not really sure why it's called little killer. Actually, I don't even really know why killer cages are called killer cages. But anyways, that's the little killer clue rule. Odd. The cell with the opaque gray circle contains an odd digit. So this is an odd digit, so it could be 1, 3, 5, 7, or 9. And those are all the rules. Pretty straightforward. If you'd like to play along, there's going to be a link in the description. And now, I'm going to get started. Let's go. Okay, so one thing we know is 2 cells that are unique have to add up to 3 have to be 1 and 2. So these are 1 and 2. That's pretty straightforward. 21. That's interesting. And then 71 across this diagonal. So 71. What's the max you can have for 9 cells, each with 3 uniqueness along 3? It would be 7 plus 8 plus 9, which would be 24. Right? Times 3. So 24 times 3 is 72, which means we have 1 degree of freedom along this diagonal. So one thing we know, okay, is it could be 6, 7, oops, not 3, 4. 6, 7, 8, or 9, and obviously this can't be 8. Plus, the 9 and the 8 must be on the diagonal. So this must be 8 and 9 in that diagonal. Now we have 21 here. What's the minimum we can have on 21? I think it would have to be 1, 2, and 3, right? Because we have 3, 1, 2, and 3. So that would be 6 times 3, which would be 18. So 21 to 18. 19 gives us 1 degree of freedom. 20 gives us 22 degrees of freedom. 21 gives us 3 degrees of freedom. So on this diagonal, we only have 3 degrees of freedom, which means the 3 can only go up to 6 at most. And therefore, this has to be a 6, which means we know exactly what's on this diagonal because we lost our degree of freedom on this diagonal. So this has to be, the rest have to be 7, 8, and 9. So we have 8 and, oops, we have 7, 8, and 9. Obviously, these can't be 8. This can't be 7 because we have a 6, 9, 8, 9. So this has to be 3, 4, 5, and 6. And then we know these are 1, 2, and 3. This is 1, 2, 1, 2, because we lost all 3 degrees of freedom there. So this is 1, 2, 3. This is 1, 2, 3. We have 1, 2, and the 3 became a 6. So these two add up to 10. And we know there cannot be a 1, 2, or 3 with it. So that eliminates 1, 9, 2, 8, 3, 7. So this has to be 4 and 6. Not 3 and 4. 4 and 6. Same here. This adds up to 10. 1, 9, 2, 8, and 3, 4 are eliminated. So this is also 4 and 6. So we have 1, 2. So this is 3, 4, 5, 6 also. Okay. Now we look at other diagonals. So this has to be 5, 7, 8, and 9, right? 8 cannot be here. Therefore, we know this is an 8. So this can't be an 8. Along this diagonal, say this was a 9. You could have 5 and 9. Actually, that does work. But then this would have to be, well, 1 and 1. So that's okay. What's the maximum these digits can be? This minimum here is 5 and 7. So that would be 12. So therefore, these two have to add up to 4. So 1, 2, and 3 is the maximum here. And we have a 1, 2, 3 triplet in row 1 now and column 1. So the rest of it cannot be 1 through 3. So it has to be 4, 5, 7, 8, and 9, and this one could be 6. This is also, okay, cannot be 3 anymore here. Cannot be 3 anymore here. So this is also 4, 5, 7, 8, 9, and this could be 6. So this can't be 3 anymore. This we have, similarly, it's 5, 7, 8, 9. It's symmetric, actually. I didn't realize that. 5, 7, 8, 9. This can't be 8. This has to be an 8, which means, well, we already eliminated the 8 there. So this is also at minimum 1, 2, 3, or maximum 3. So this is 1, 2, 3, 1, 2, 3, which again means that this is 4 through, this can't be 3. This can't be 3 because we have now column 9 has a triplet of 1, 2, 3. Row 1 has a triplet of 1, 2, 3. So this is, again, 4, 5, 7, 8, 9, with that being a 6. This is 4, 5, 7, 8, 9, with that being a 6. So 3 has to be on that, well, okay. 3 has to be on this diagonal. That's interesting. So this is at maximum in these two cells, 3 and 6, which is 9. 25 minus 9 is 16. So that means this is at minimum 16. So it cannot have a 4, 5, or 6 because a 6 would have to have a 10 with it to add up to 16. So this is 7, 8, 9. This is 7, 8, 9. Seems okay so far. 7, 8, 9. So we've got this diagonal kind of solved. I don't know. Eight's here. 8 has to be one of those two. 8's here. Can it be 3 and 4? I think so, right? 3 and 4 add up to 7. 25 minus 7 is 18, but this could be 9 and 9. Right. This is 1, 3, 5, 7, 9. Okay, so of the diagonals, we've used 71, we used 21, we've used 10, we've used 10, we've somewhat used 16, we've somewhat used 16, we've obviously used the 3s. We've somewhat used 25. So we only have 30 left. Okay. Yeah, then it's probably going to come down to interactions and how those work. Okay. Interesting. Anyways, what are we looking at here? Can this be 8? Yes. Can it be 9? Yes. 5, 9 would be 1 and 1, which works. Maybe not, actually. I don't know. I have to figure that out. So the 16s are interesting because, yeah, they limit things somewhat. So that's not completely done. 25 is not completely done. The 30 is not completely done. So those are the only ones that are not really completely done. Should we look at the 30? I don't know. It could be 4, 5. Yeah. The 30 is not very limiting right now. Does it tell us any information along with the 25? Not really. Yeah, not really. It just makes it 55 and then Yeah, we don't really have any more information. Um, let's start coloring. That always seems to help. We'll have red, yellow, and blue. So this is red or yellow. This can't be red. It could be, this is yellow or blue. This is also yellow or blue. This is also yellow and blue. This is also yellow or blue. This could be blue, red, or yellow. Blue, red, or yellow. This is blue, red, or yellow. This has to be red and yellow because of this blue. This is blue, red, or yellow. This can't be yellow. So this is blue or red. This is blue, red, or yellow. So far this is not helping very much. Blue, red, or yellow. Okay. Huh. Hmm. Do we have anything here which is limiting? Not really. Hmm. 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 So if this is 9, the 5 has to be with it, right? Oh, the 5 always has to be here, right? If we don't have a 5 in one of these two cells, the minimum would be 7 and 8, so that'd be 15. But then you have two digits we're trying to add up to 1 without a 0. So this has to have a 5. So the 5 has to be here. Similarly, the 5 has to be here. So this cannot be 5. This cannot be 5. This cannot be 5. That can't be 5. Ah, and we have a 7, 8, 9 triplet then. So this cannot be 7, 8, 9. Similarly, probably here, this is 7, 8, 9. Oh, no, not there. So it's only on row 1 and I think column... No, it doesn't even have that. Why does that... Oh, because of the 30. So then we have row 1 too. So this can't be 7, 8, 9. So this is 4 or 5. Okay. Right, so column 25 made limits 2. I don't know if this is helpful. Anyways, let's color these, I guess. Green, pink, and orange. Okay. So this is pink and orange. This is pink and orange. This could be green, pink, or orange. This is green, pink, or orange. Green, pink, or orange. 8 cannot be orange. That's not helpful. This is not pink, so this is green or orange. This could be green, pink, or orange. Hmm. Hmm. Okay. What? We don't have any. So 5, 9, this would be 7. Hmm. Interesting. Okay, so if this is 9, that forces things a certain way. So this would have to be 8 and 8 because this is 16. This would have to be 16 at least. So then this would have to be 3 and 6. So this would be 4, 5, 4, 5. This would be 6 then. This would be 4. This would be 6 then. That would be 4. Okay. What does that tell us? I don't know. This becomes 5, 6, 5, 6. So this is 3 and 4. This can't be 4. This obviously has to be 8. What does this tell us? I don't really know. Hmm. How did I add a 1 there? Okay, well, whatever. Could be all 3. I don't know how I added a 1 there. There's no 1 there. Yeah, so again, if this is 9, this would be 8. This would have to be 8 and 8. Which means this is an 8. This can no longer be 9. This can't be 8. This can't be 8. This can't be 8. This has to be 3 and 6. So this is 4 and 5. Which makes this 6 and this 4. Which makes that 6 and that 4. So none of these can be 4. None of these can be 4. This can't be 5 or 6. This is a 3, 4 pair. This all seems kosher. Hmm. The pink is now 8, so these can't be pink. This would be pink. This would be pink. This would be pink. This would be 4 and 5 added together. They could be 5. Could be 4. I don't think this helps us any. Hmm. Yeah, it's not that limiting. So, I don't think we should go down this path right now. We still want to remove the 1. Oh, we do know it's 4 and 5. So what's this at most? This is 4 and 5. So this is at most 10. And this is 19. So these two would have to add up to 11 at least, I think. Yeah. Because you could have 5, 9, and 5. And that would add up to 11, 19. 30 minus 19 is 11. So this has to be 2 through 9. But that's not very limiting. um, Interesting. Let me pause a moment. I need to go to the bathroom right now. And we're back. Okay, let's continue. Um, hmm. Okay. What does this mean? Hmm. 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 What's the maximum? Well, it doesn't matter because you could have 2 and 9. Hmm. Yeah, I'm not sure if the coloring's really helping either. Hmm. Yeah, let's remove all the coloring. The coloring is just not helping. Uh, mm, hmm. Okay, this has to be 3, 4, 5, and 7. 3, 4, 5, and 7. Is that helpful? I mean, it's helpful a little bit. Oh, we do see something here. Okay, so this 4, 5 cannot be here on this 4, 5. So it must be on this 4, 5 for box 5. Therefore, this one cannot be the same as this. Therefore, we know specifically this is 9. Now, what that tells us, I have no clue, but these have to be different. So there cannot be a 4, 5 in the rest of row 5 or column 5, except for these squares and then the middle squares, right? Because if this is 4, 5, well, we know, okay, whatever 4, 5 is here, it has to be here, right? For box 5 to have that green one. Same here. For this 4, 5 to be in box 5, it has to be in this row. So the rest of row 5 and column 5 cannot contain a 4, 5. So this cannot. That was very clever. I like that. That has to be 7, 8, 9 then. And then we have a 7, 9, 7, 8, 9, 7, 8, 9 triplet. This is similar. This has to be 7, 8, 9. We have a 7, 8, 9, 7, 8, 9, 7, 8, 9 triplet. So this can't be 7, 8, 9. This can't be 7, 8, 9. You have 4, 5, or 6. Now, I don't know if that makes any difference, but, I mean, we do have something there, right? Um, yeah. So that gives us something. The problem is we don't know what. Um, these don't have to be different as long as they're not 7. Hmm. Right? They both can't be 7 because we have a 7 here or a 7 here. So if they're both 7, that eliminates all 7s from box 5. Um, so this adds up to 9 specifically. So this would be at most 18 here because this is either 4 and 5 or this is 4 and that's 5. So that has to add up to 9 plus 9. So that means these two digits have to add up to 12 at least. It could be more. It actually, we know it adds up to 12 or it adds up to 14. Right. So it either adds up to 12 or it adds up to 14. We know specifically because this has to add up to 9 and this is 7 or 9. So if it's 9 and 7, then it adds up the two digits add up to 14. If it's 9 and 9, the two digits add up to 12. Not too much information there though, unfortunately. Okay, so let's fill this in with no 4, 5, or 6. So this is 1, 2, 3, 7, 8, 9. This is 1, 2, 3, 7, 8, 9. This is 1, 2, 3, 7, 8, 9. This can't be 8 though. 1, 2, 3, 7, 9, and this could be 8. Now that's interesting. Does it tell us anything? I don't know if it does. Maybe not. Mm-hmm. So we know the green has to be one of these two. We know the pink is one of those two. The pink has to be either here. Oops. Here or here. Pink could be this. Pink can be one of these three. Interesting. Hold up. If the green is a 4, this has to be 5. And then this can't be pink. So this would have to be pink. If this is a 5, I guess it could be 4 or 6. Hmm. Hmm. Does that tell us anything? I don't know. Uh, hmm. Again, so this is 9 at most. Because this is 9 at most, this has to be 16 at least. Which means you either have a 7, 9, an 8, 8. Or you could have an 8, 9. Or you could have a 9, 9. What that means, though, is that I don't think you could have an 8 or a 9 along. So this. Oh, no, that's not true. You know you can't have a 8 or a 9 along either the column 4 or the row 4, but the other one could be. Right. I was hoping that that would have limited this, but it doesn't. Oh, one thing is, no, you can okay. One interesting thing. The 3 has to be either here or here, right? If this is not 3, this has to be 3, right? Which makes that a whoa, interesting. A 1 because it has to be 12 at least here. Okay, that's the break-in that we were looking for. If this is not 3, the 3 has to be somewhere along this diagonal. But if one of them's 3, the other one has to be a 1. Which means that we have no 1, 2, 3 in row 9 if that's the case. Or if we tried to put the 3 here, this would have to be a 1. And then we have no 1, 2, 3. There's no 3 in column 1. So this one then has to be 3. And I think that's similar logic here too, right? Because of the limiting factor of the 16. So this one, if this is ever 3, that would have to be 1, but then the 3 is eliminated here, the 3 is eliminated here, and there's no more 3 in column 9. Same way if you go this way, and then, okay, so therefore, we know in box 3 and box 7, the 3 has to be in the corners. And we celebrate, because the 3s are in the corners. That's 3 in the spotlight. Okay, and then we can eliminate all the 3s from Sudoku. And now we get some more information, which is nice. We have a 1-2 pair now in column 2, row 2, column 8, and row 8. So we can eliminate 1, 2, and actually column 4, column 6, row 4, and row 6. So we can eliminate 1s and 2s from all of those places. So this is 3, 4, 5, 6, 7, 8, 9. This cannot be 1 or 2. This can't be 1 or 2. This can't be 1 or 2. So this is also 3, 4, 5, 6, 7, 8, 9, 3, 4, 5, 6, 7, 8, 9. 3, 4, 5, 6, 7, 9, 3, 4, 5, 6, 7, 9, 3, 4, 5, 6, 7, 8, 9, 3, 4, 5, 6, 7, 8, 9. This is 3, 4, 5, 6, 7, 8, 9. This is 3, 4, 5, 6, 7, 8, 9. Oh, this has to be 1 or 2. Where's the 1 or 2 in column 5? Where's the 1 or 2 in row 5? It has to be here. So this is 3, 7, this is 1 or 2. This is 1 or 2. This is 1 or 2. Okay, and then we have 3, 4, 5, 6, 7, 8, 9. This can't be 8. 3, 4, 5, 6, 7, 9. And these are 3, 4, 5, 6, 7, 8, 9. And the 1, 2s now are distinct, so the coloring might help here. Okay, so let's remove the... I don't think the green and the pinks are really helping right now. And this, we want more colors. So we're going to make this red and orange. So then this becomes red. This is orange. Which makes that red and this orange. Which makes that red and this orange. Which makes that orange, this red, this is orange, this is red, which makes that orange, and this is red. And that orange, this is red, and that's orange. So, interestingly enough, one of these has to be 1 and 1. So it adds up to 14. One of these has to be 2 and 2, which means this adds up to 12. So it's 5 and 7. Neither of them can add up to 3, which means 5 and 8 is out in either of these little killer clue diagonals. So this cannot be 8, and this cannot be 8. Which leaves 8 in box 3 and 7 in only one place each. So this is 8, this is 8. So this cannot be 8. This cannot be 8. These two can't be 8. These two can't be 8. So now we have 7, 9 pairs, maybe. Maybe. We don't know. Like, yeah. If this is 8, this still could be 7, 9. That still works. So, yeah, that's not as much information as this. Okay, so let's start coloring these then. So we're going to make this blue and this pink. So these are pink. Which means one of these is pink, which is not very helpful. Oh, we do have more information. Because one of these is with orange, and one of them's with red, these 7 9s have to be different. Which gives us very important, well, some important information. Right, because these have to be different. So one of these is 1 and 1. So that means this has to add up to 14, if that's 1 and 1. So say this was 1 and 1. This, whatever this 7 and 9 is, this one is not. So we're going to make this one blue, I guess. This 7 and 9 goes with the red, whatever 1 and 2 is. So if it's 1, this is 5 and 9. If it's 2, this is 5 and 7. However, we know the orange is also there. So it would have to be the opposite. So if the red is 1, the orange has to be 2. So this would be 2 and 2, which would force us to be 5 and 7. And this would be 5 and 9. Therefore, these have to be distinctly different. So we know this is pink, and we know this is blue. So that can't be... So then the blue could be here, the pink would be here, right? But that means both 7 and 9s see that cell. So this cannot be 7 or 9, so this is 8. which means this can't be 8. This can't be 8, and this can't be 8. So this has to be pink, and this has to be blue, which means this adds up to 16, which means we know this now has to add up to 9. So this has to be 3 and 6. So this is 4 and 5. Now we have 4 and 5, 4 and 5, 4 and 5, 4 and 5. And now we have the green, whatever, pink one where we had. So this one, that forms a 4-5 pair in row 1 and column 1. So there cannot be a 4 or 5. So therefore this is a 6. This is a 6. This is a 4. That's a 4. And then we have, these can't be 4. These can't be 4. So we have a 5, 6, 5, 6 pair in box 9, so then none of the other cells can have a 5 or 6, so this becomes a 3, 4 pair. This can't be 6, obviously. This can't be 4, 4, because of that 4. This can't be 4, 4. This can't be 6 or 6. So now we have some interesting bits. So now we know this is 3, 6, 3, 6. This is 7, 9, 7, 9. Both of these 7 9s see that square. So that means these both, 7 and 9 is eliminated from that cell. So this has to be 8. This has to be 9. Let's just do regular Sudoku to eliminate the 8s. These can't be 8. This can't be 9. This can't be 9. These can't be 9. These can't be 9. Okay. So the blues and the reds go together. So if the red is 1, the blue is 9. If the red is 2, the blue is 7. The pinks and the orange goes together too. We know these are different again. We don't know which one these are, unfortunately. So, okay. So now we have all the information from 71, all the information from 21, all the information from 3, all the information from 10s. We have all the information from 25. Now I think it's just the 30 now. The 16s are already pretty much taken care of. So blue is one of these two. Pink is one of these two. Yeah, I see it. Say this was a 7. If this is a 7, then this has to be 9, and that has to be 7. But then both 7s would eliminate all the 7s in box 5, which makes that break. So therefore, both of these have to be 9, and that's 7, which makes that a 9. Which means this can't be... let's remove all the 9s from Sudoku. This can't be 9. This can't be 9. So one of these has to be 5, 7, and one of these has to be 5, 9. This can no longer be 9, and this can no longer be 9. So if this is 5, 9, this has to be 9. If this is 5, 9, this has to be 9. And one of them has to be 9. So both of these 9s see this cell. So that can't be a 7. Or sorry, that can't be a 9. This has to be a 7, which makes that a 9. So now we can remove 7s here from Sudoku. Remove the 9s, remove the 7s. So now we have Sudoku now. Not Sudoku. We have the last killer clue. Okay, what can it be? So we know this is 9 and 9. So these two add up to 12. So it can only be 3 and 9 or 6 and 6. I don't know if that tells us anything, though. If it's 6 and 6, it doesn't work. If this is 6, that eliminates 6 here. If this is 6, that eliminates 6 here, and there's no 6 any longer in box 1. So this has to be 3 and 9. I don't know what that tells us. So one of these is 3. One of these is 3. So if this is 3, that has to be 3. If this is not 3, this is 9, that has to be 3, which makes that 3. So, okay, I think that eliminates any 3. So there has to be a 3 here. There has to be a 3 here. If this is a 3, that becomes a 3. If this is a 3, that becomes a 3. So there's always a 3 in row 2 or column 2 in these two cells. Therefore, there cannot be a 3 in any of the other cells in row 2 and column 8. Therefore, this has to be an 8. This has to be an 8. This can't be 3 or 8. This can't be 3 or 8. So this can't be 8. This can't be 8. Where's the 8 in box 6? It has to only be here. In box 8, it has to only be here. Okay, so we have that information. So 8s are all filled out. This is 3, 6, or 9. Unfortunately, that doesn't tell us that much information there. So now we have all the arrow information. Okay, now we need one last break-in. Okay. How do we differentiate, essentially? Because these are all symmetrical now. And the only differentiation is the 20... No, that's symmetrical. So these are all symmetrical around this diagonal. So how do we differentiate? It's from this. So 4, okay. This can't be 4. This can't, yep, we have a 3, 5, 7 triplet. That's the differentiation. And that's the last break-in. So therefore, we have a 3, 5, 7 triplet in row 8, which means there cannot be a 3, 5, or 7 in the rest of the cells in row 8. So this is a 4. This is a 3. That makes this 7, and now we're just doing Sudoku. So this is 5, 9. This is 7. This has to be 9. Since this is the blue, this has to be 9. This is 5 and 7. So now this is 5 and 7. This is also 7. So this is 4. This is 5. This is 5. This is 4. This has to be 3, which forces that to be 9. So this is 6. This is 3. This is 6. Now we know what the reds are. The reds have to add up with 12. So 2 times the reds has to add up with 12 to be 16s. Therefore, the reds are 2s. And the oranges are 1s. So this now we're just doing Sudoku. So this is 5, this is a 6, this is a 5, this is a 6, this is a 3, this is a 5. This is a 4, 7 pair. Oops, we missed a 2. I don't know how we did that. So this becomes a 3, this is a 6, 4. Which makes that a 4. This is a 3. This is a 7, 5, 7, 6. All of these are now Sudoku, 4, 4, 3. And that's the solution. Nice. I like that. I like those break-ins. Those were very clever break-ins. And the little killer clues were very key, obviously, into forcing those break-ins. And then you had the last circle being the last break-in. Very clever, very clever. I liked it. Very fun, and I hope you had a fun time too. And I'll see you next time on Frank Puzzles. Take care.